Welcome to another unit of the ISM Statistics 1 exercise set, this time with an exercise on linear regression. Let's consider the exercise. It is assumed that a relation exists between the age and the time spent on watching online TV series. It is furthermore assumed that the age impacts the time spent. The data summarized in the table below has been collected. Calculate the coefficients of a regression line that describes the relation between the two variables. Interpret the coefficients calculated on a previous part. And final part, calculate the coefficient of determination r squared. So let's work our way through this part by part. Before we can start calculating anything at all, we have to do some preliminary work. So we need to take our table and have a short thought about this because, the exercise clearly states the time spent depends on the age. So the age is the independent variable x, the time spent is the dependent variable y. This in mind, we can extend this table a little bit by adding 3 additional rows. In the first row, we add the squared x variables, so we go 32 squared, 23 squared, 32 squared, 37 squared, and 19 squared. Then we do the same thing for y. Here we have 4, 0, 144, 576, and 16. And finally, we add x times y. So we have 64, 0, we have 384, 888, and 76. Though we are not interested mainly in those values, but first in the value if we sum all of them up, giving us these values, and then divide them by the number of observations so that we get the average values. So the average time spent watching series is 8.4, the average age is 28.6, the average x squared is 861.4, the average y squared is 148, and the average x times y is 282.4. That's actually the values we are going to use in solving the next few parts of this exercise. With the first part, we need first to calculate the coefficients of the regression line. So the slope is given as b, and we can calculate b by using first our average of x times y, so the 282, and subtract the average of x times the average of y, so subtract 28.6 times 8.4. All of this is divided by the average of x squared, here being 861.4, minus the average of x to the power of 2, so minus 28.6 to the power of 2. We insert the values, calculate this value, estimate this expression, and we get as a result 0.9705. This being the slope of my regression line. Then we can use this slope to calculate as well the intercept. The intercept is given here via the average of y minus b times the average of x. So here we have 8.4 minus 0.9705 times 28.6. If we insert those values and estimate this, we get as a result minus 19.3563. So we can use the results of this part A to directly answer part B as well and interpret the coefficients. Here we can see, interpreting the intercept doesn't make so much sense. This would mean if we have someone who is 0 years old, he would watch approximately minus 19 hours. So not always does it really make sense to interpret the intercept, because this is just extrapolation. However, we can clearly interpret the regression slope. Here, the 0.97, or roughly 0.97, means for each additional year which someone is old, he will spend roughly 0.97, so more or less 1 hour more watching series. So this can be interpreted intercept not so much. However, this answers part B as well, and we can turn to part 3, calculating the coefficient of determination, the R-squared. For this, however, we need one more intermediate step, and this we get by adding one additional line to our table, and in this line calculate y hat squared. What's y hat? Y hat we get if we insert x into our regression line. So what we're going to do here is, for example, for the first one, take 32 and then calculate 32 times 0.9705 minus 19.3563. This result is then squared and gives us in total 136.883. Then we do the same thing for the second part. For the second we have 23, so we calculate 23 times 0.9705 minus 19.3563. The result again is squared and gives us a value of 8.7924. And we do the same thing for the third, the fourth and the fifth value. Sum all of the 5 values up and divide them by 5. So we get here as a result 111.4748. We compare this with the y squared. We see they are not so far apart from each other. This is due to the fact that the last one explains more or less how much of the variance of the dependent variable can be explained via the regression line. That's why we use this in the coefficient of determination. And we see this here if we take a look at the formula for the R squared, which is given as follows. Here on the upper part we have what we just calculated, y hat squared on the average of this, so the 111.4748 minus the squared average of y, so 8.4 to the power of 2. All of this divided by the average of y squared of 148 minus again the average of y squared, so 8.4 to the power of 2. We insert the values and get as a result a value of 0.5283, meaning that our regression line is able to describe a roughly 52.83% of the variance of the time spent watching TV series. Well, and this then concludes this exercise. I hope you all enjoyed watching this and, well, possibly learned something from watching it. So, see you and goodbye.